Hi, and welcome to the first video for the Core 3 assignments. I'm going to go over a couple of examples for the assignment, which hopefully your first port of call if you get stuck on the assignment is to have a look at this video and get some help from this. If you're still stuck afterwards, come and speak to me and it'll all be cushy. Okay. So, typical question, section A. Integrate 4x squared. Let's get this. There we go. Integrate 4x squared multiplied by 3x minus 1 to the power of minus 2. Now the trouble is this minus 2 means that we can't integrate it with normal techniques. The fact that there's a bracket to the minus 2 but something function to the power of minus 2, this makes it quite tricky. We've also got this 4x squared in the middle. Okay, now this looks on the surface quite a tricky function to integrate, but actually once we perform the substitution it becomes a lot easier. The key is we look at, just as we did for the chain rule, this is kind of the opposite of the chain rule really, we make a substitution for the brackets. We will say that u is equal to x cubed minus 3. Okay? Let u equal x cubed minus 1. Okay. Now we need to change the integral. At the moment the integral has got everything to do with x squared, x cubed, and dx. Now this dx is a reminder that we're differentiating with respect to x. So we need to change this from a dx to a du. To do that, we'll differentiate this simple function, the substitution rule, u is equal to x cubed minus 1. So, du dx is equal to 3x squared, that's fine. The rule is that although we should never treat du dx as a fraction, whenever we want to, we can. That's a very very solid rule. But we don't want dx, we want du. Okay, so I'm going to rearrange this as if it was a formula, even if it wasn't, to make dx subject. Okay, so that's quite simple. That will mean that du divided by 3x squared is equal to dx. Okay, so we're almost there. What I'm going to do now is I'm going to substitute x cubed minus 1 for u. I'm also going to substitute dx for du over 3x squared. We'll worry about this 4x squared in a second. Okay, so that means we get the integral of 4x squared multiplied by u to the power of minus 2 multiplied by, well, we have dx, but it's du over 3x squared. Okay, this is all quite nice. Move that down a bit. The reason why this is quite nice is we can see we've got an x squared at the top. We're divided by an x squared. So what's beautiful about this is that the x squareds completely cancel out. So we end up with an integral just involving u. We've got this 4 divided by 3, which is 4/3, but I can put that outside the integral. And then it becomes u to the power of minus 2 du. Now this is quite beautiful what we've done. We've gone from a really nasty looking function to integrate, and by being a bit clever, substitution rule, we have made it look something which is quite a lot easier. Okay, and this becomes 4/3, and then we can use the usual rules of integration. Add the power, so it's u to the minus 1. Divide by the new power, so divided by minus 1 just means, well, I'll divide it by minus 1 just for. Okay, and remember we need a plus c. Let's extend the page. That means that we end up with minus 4u to the minus 1 over 3. Okay, so that minus 1, the minus 1 there just has, divided by minus 1 just has the effect of turning everything into a minus. Need plus c as well. And then just to complete it, because the question was in x, we need the answer in x as well. So it'll be minus 4 u was x cubed. Remember what it is. X cubed minus 1 to the power of minus 1 over 3 plus c. The power of minus 1, that's been nice. It's just basically saying this is a fraction, so I might make it a little bit nicer and write it as minus 4 over 3 lots of x cubed minus 1 plus c. And there's your answer. Okay, so the integral of 4x squared x cubed minus 1 to the power of minus 2 dx. To that. Okay, and there's your answer. You leave it exactly like that. Now, this isn't going to work all the time. What's crucial here is that the bit inside the brackets, if we differentiate that, if we differentiate x cubed, we get an x squared. Outside the brackets, we also have an x squared. And the reason why this works is that if we differentiate the brackets, we get something similar to what's outside the brackets here, this multiplier. And the reason it works is that by using the substitution rule and then replacing dx, we are able to cancel out those x squareds. If, for example, this was a, say for example it was a nothing was there. Not there. Take out the x as well there. Never mind. If it was just 4x, this wouldn't work. Because the substitution rule would still be the same, but the x's wouldn't cancel, would still end up with an x at the bottom there. Okay? So it's crucial for these ones, and they're not going to give you one which doesn't cancel, because not in this kind of form, but it's crucial to the x's cancel, and the only way that will work is if inside the brackets, if we differentiate it, we get something of the form of outside the brackets. Okay, so that's an example using the rules of integration we've already come across. We'll go over another example now, and it says evaluate the integral between 1 and 2, so this is definite integration now. This is an area under the curve between 1 and 2 of 6x plus 12 and x squared plus 4x minus 1 dx. Now, this is a fraction. Fractional function. And for this, you should be instantly thinking, okay, this is going to be natural log, okay, of something, log x. Okay. The rule is, and you need to really remember this, is that if we have the integral of a fraction, and in particular, if the fraction, if the denominator of the fraction is a function, and the numerator is the derivative of that function, if we differentiate it, the answer will be ln modulus of f of x plus c. Okay? Don't need to worry about the proof, but you do need to know how it works. So, we can see from here, if we differentiate x squared plus 4x minus 1, we get, well, that's a little bit differently. If we write 6x plus 12 over x squared plus 4x minus 1 as f dash of x over f of x, you're going to see it's not going to work because our function f of x, that is f of x. If we differentiate this, we get f dash of x is equal to 2x plus 4, which isn't the same as 6x plus 12. However, we can play around with the 6x plus 12, so it does look like 2x plus 4. And the key is to take a common factor out. Now, we want 2x plus 4. I can see here, if we take a common factor of 3 out of 6x plus 12, we'll get 2x plus 4. Okay, so the integral becomes 3 lots of 2x plus 4 all over x squared plus 4x minus 1 between 1 and 2 dx. Okay. 3, I can, it's 3 here, I can take it outside the bracket, so we get outside the integral. 3, 1 and 2, 2x plus 4, all over x squared plus 4x minus 1 dx. Now we've got it in the form f dashed of x over f of x. So this becomes, quite simply, 3 lots of ln the modulus of x squared plus 4x minus 1 plus c. And we're done. Simple as that. Okay. Oh, I've made a mistake. This is definite integration, so we can get rid of the c, and this needs to be square brackets between 1 and 2. Okay. So this becomes 3 lots of ln. Let's substitute 2 in. So we get ln of 2 squared, which is 4, plus 8, which is 12, minus 1 is 11. Take away 3 lots of ln. 1 squared is 1, 4x is 4, 5 minus 1 is 4. Okay. So this becomes 3 lots of ln. Well, 11 over 4 is one way of writing it using normal log rules. Okay, and because this is the exact answer, you could get this, put this into a calculator, and if you put it into a calculator, let's get a calculator up. So 11 divided by 4 is 2.75, and we want the natural log of that, and then times that by 3. So 3.033. Okay, so I hope that's helped you. Hasn't, come see me and I'll explain it further.